Okay, so the assessments are going to have only one of these like little specifiers. I just gave you a couple here, so you could work through a couple on your formative assessment. So this is, instead of 5 meters horizontally, this is now 1.5 seconds after it leaves the edge of the cliff. So that goes in here, 1.50, which kind of takes the fun out of moving the time over. I always like that part, but you know. This is 0, this is negative 9.81. I can now solve all these things independently. That guy's 0 because it's a cliff problem, right? It's purely horizontal velocity. Let's see. Oh, yeah. And then the other thing we know is since it's part of the same problem, we know this is still our 7.0908 that we did in the first part of this problem. Not part A, but the very first part. 7.0908. So do me a favor and don't mess that part up, right? Okay, so let's figure out S here. S is always UT, right? So horizontally, right, our S is, what is it, 7.0908 times 1.5. Okay, there it is, times 1.5. And that is 10.636. Right? So there it is. That's how far over, right? And then S, let's do our S vertically, right? S vertically, I'm going to use S as UT plus 1/2 AT squared, right? Now, of course, there is no initial velocity, so that goes away, right? So that equals 1/2 negative 9.81 times 1.5 squared. So let's type that in, 0.5 times. All right, negative 11.036. Right, so there it is right there, negative 11.0 meters in the y hat, right? And that's the way you should write it. Write it something meters x hat plus something meters y hat. If you say over and down that much, that's okay too. This is better though. Okay. Then it says, okay, so this is negative 11.036. Okay, then we want to find our final velocity. I choose v equals u plus at. Right? So that equals 0 plus negative 9.81 times 1.5. That's negative 14.175. I'm sorry, negative 14.715. Dyslexics should not teach physics. Okay. I'm all you've got, you poor kids. All right, there we go. All right, I just drawing those horizontal lines too is very satisfying. Okay, how sad is my life? Okay, so this velocity here is negative 14.715, right? And so it says, what is the velocity as in vector components and as an angle magnitude and a magnitude, right? So in vector components, it would be that many meters per second in the x direction plus, right, this many meters per second in the y direction. So here it is right there. Right, put little hats on these guys, you're all set. Round it to 3 places. Then it says do it as an angle and a magnitude. So now we got to draw a picture of this guy. Oops, failure to draw a horizontal line. Okay, there we go. There's our horizontal. Here's our vertical. Notice that the vertical is bigger than the horizontal, right? We're going to I'll find this angle, this side, right? So this is 7.0908. This is 14.715. And somebody will always say, why didn't you put the minus sign on there? So let's do that, right? And these are all meters per second. Our magnitude is the square root of 7.0908 squared plus 14.715 squared. Again, don't put your minus sign in there. If you have a TI calculator, you must use these parentheses because in my opinion, it incorrectly says the square of negative 2 is negative 4. Okay, so yeah, it interprets that as the opposite of that squared, which is weird. Okay, so square root of 7.0908 squared plus, okay, 16.3 is my magnitude here. That, by the way, is the speed. 16.3 meters per second, right? The magnitude of this is the speed of the thing. Don't forget that, right? Okay, it's not this, it's not this, it's the hypotenuse is the speed, right? And then let's find the angle just for kicks. Up. Okay, so this angle here is the inverse tan of 14.715. Notice I'm ignoring the minus sign because I'm not sufficiently clever to really know what it means. Okay, so 7.0908. What is that? Okay, so inverse tan 14.715 divided by 7.0908. 64.3 degrees. Okay, so if you draw this picture here, you label this 16.3 meters per second, this 64.3 degrees. Whoa. 64.3 degrees. Okay, if you do that, you are just golden. You have to draw a picture. It's got to have an arrow on it, right? You got to label which angle you found. Okay, it's customary to find that angle, but you know, you can be creative. As long as you label a correct angle, you're good. And I know you know it.